Hello everybody and welcome back. We're up to our 7th question on the 2009 Euclid contest. You can get a copy of this contest, just to remind you, by clicking the very first link in the description. So let's see what question 7 has in store for us. Light bulb question and a written question. I think that's the last time this happens. But what do we got for our light bulb question? The parabola x squared minus 2x plus 4 is translated p units to the right and q units down. The x-intercepts of the resulting parabola are 3 and 5. What are the values of p and q? Okay, so we have a parabola, something like this, and then we shift it over by p, and it goes down by q, and then I guess we have, well, we know 3 and 5. So if I'm going to figure out, well, what are p and q, how far over and how far down we've shifted, it would be useful if I had maybe some points that were easy to predict on the original parabola, and I can see, well, where does that new point end up? Okay. And as I started this sentence off, I thought, oh, that's easy, I'll just move the roots. Except, while roots can shift over, they don't shift down. Okay, so what I mean by this is, if I've got, say, parabola like this, and I shift over and down, well, like, even if I just shift down, that's what is really going to illustrate my point. If I just pull that down, the parabola sort of takes a lot longer to reach the axes, and so these guys are now further apart. But the original points that were my roots have now moved down here, and I can't really predict where they are. And now that I'm thinking about it, I'm pretty sure, what is it, x squared minus 2x plus 4 is x minus 1 squared plus 3. Yeah, this doesn't even have roots in the first place. Question might have been more fiendish if the first one had roots. So what can I do? Well, if I can't use the roots, I guess there's sort of only one point on a parabola that I know, okay, if I just shift the parabola over, up, down, sideways, anything other than sort of a stretching action, the vertex will tell me exactly what's happened. So I guess we move to the vertices. Okay. Well, I just did the calculation. I'll do it a little slower, but I'm going to get that first parabola in vertex form. So how do we do that? Well, we complete the square. So we add 1, subtract 1, and we still have the plus 4. This first bit becomes x minus 1 squared, and then the minus 1 and the 4 become a plus 3. And so 1, 3 is the vertex we start at. Okay. Now, by shifting, over by 10 units and down by 7 units or whatever, we don't change the stretching or anything like that. So our new parabola, so this is the old one. The new parabola, I know he's gonna have to look like y equals some scaling factor, and then I'm told the roots are 3 and 5. It is 3 and 5, right? Yeah, 3 and 5. So the new roots are 3 and 5. Now the question is, all right, can I get the vertex from here? And if I knew what the a was, yeah, just expand this out, complete the square just like I did up above. But what is this a value? Well, a lot of people, I think, when they did this question, kind of ignored this. But when I shift a parabola over and down, I don't change the scaling factor. I don't stretch the parabola out. I don't squish it. So if I have a leading one here, I should have a leading one here as well. So it's okay to actually ignore this. But it is something to think about, because if they had, something like, you move p units to the right, q units down, and then you stretch by a factor of r, that could change the question entirely. Okay? And we'd have something like r times x minus 3, x minus 5, and we need a bit more information to figure out what r now is. Okay? So it is something to think about. The question could very easily be changed so that the people who didn't even think about this end up not knowing what to do. Okay, so, well, let's expand this out. X squared minus 8x plus 15. Now, you can do this. Of course, you could also, I suppose, say, well, if I know the roots, parabolas are nice and symmetric, so if you know where the roots are, just take the midway point. So 3 and 5, the midway point between them is 4. 4 is going to be the x-coordinate of the vertex. So we could do 4 minus 3, 4 minus 5, and get a vertex of minus 1. But, I mean, doing it this way, completing the square is fine as well. Half of 8 is 4. 4 squared is 16, so we add and subtract 16. We get x minus 4 squared minus 1. So our new vertex is 4 minus 1. Either expand and complete the square, or use symmetry of the parabola and get the vertex that way too. But, alright, so what do we do? Well, it's p to the right. So 4 is 1 plus p, and minus 1 is 3 plus q. So p is going to be 3, and q is going to be... Oh, sorry, this should be a minus, because they said q units down. So q should be 4. Right. I had it in my head, I didn't write it properly, but there we go. And that's all there is to it. Okay, so that was 7a. What can we do for 7b? Looks like we have another parabola. In the diagram, D is the vertex of the parabola. The parabola cuts the x-axis at A and C, and we know the coordinates of C, but no one bothered to tell me the coordinates of A, or of D, actually. The parabola cuts the y-axis, so we've got an intercept here at 0, negative 4. The area of ABC is 4. What's the area of BDC? Okay. Well, BDC is another triangle, so I start thinking of ways to calculate the areas of triangles. Now for ABC, I know that it's an area of 4. And I know the coordinates B and C. I don't quite know the coordinates of A. Now there are formulas you can make to get the area of a triangle given the coordinates. They're fine. I don't think I want to use them because, well, one, I don't remember them off the top of my head. But 2, I think there's a lot of different values A can be to the coordinates could have, although I guess A has to be on the x-axis, so that would certainly narrow things down. But I guess ultimately, I just don't remember the formula. It's something with vectors. I could rederive it right now if I wanted to, but we don't need vectors to do these questions, so I'm not going to do something that I think a lot of people don't know. Alright, so let's draw our picture a bit. B down here. There, connect up to C. We need A, and we need D up there, the vertex. Okay. So in terms of A, B, C, I know C is 4, 0. I know B is 0, negative 4. I don't know what A is. But I can exploit the fact that the x and y axes are perpendicular. And so B to the origin, which is a distance of 4, is a height for this triangle. It's kind of hard to see. If I flip things up, I've got B up here, and he goes to C, he goes to A, just sort of flipping the thing, and drop a perpendicular down from B, that would be a perfect height. So if I knew the base, which is the difference between A and C, then I could figure out the area. So the area would be 4, which is 1/2 base times height. The height here is going to be 4. So we're going to have 2 times the base. So base is 2. So the difference between A and C is 2. And that means that A is 2 units over. He's 2, 0. Right? They do say in the diagram. So they are making reference to the diagram. So we can use the fact that A is to the left. So no, A is not at 6, 0. It would also give me an area of 4. But we're using the fact that the diagram has A to the left of C. Okay, so I know A, which is, just an extra little piece of information we've got, but A isn't really mentioned when we talk about B, C, and D, so it's entirely possible that we just sort of did all that work for nothing, but I very much doubt it. Because now I think we should be able to get D. We know the roots, so just like what I mentioned in the last one, D is going to have an x-coordinate that is the average of the roots. And I know the roots for my parabola, and I know B is on the parabola. So I might say something like 2 and 4 are roots. I guess we don't have to use the symmetry argument either, but 2 and 4 are roots, so y is equal to some scaling factor, x minus 2, x minus 4. D, incidentally, will be 3 something. Like 3, 2, or 3 some positive value based on the picture. Okay, but we know B is on the parabola. And we know that B has coordinates -4, or 0, -4, so plug those in. And I will get A times -2 times -4. So A should be -1/2. And it's a downward-facing parabola, so we would expect a negative A value. Alright, so I know my parabola. I can put it in vertex form and figure out what D is, or I could say something like the following, which I didn't really write in A part, but I'm going to use it now. The vertex lies on the vertical line between the roots, and you can say by the symmetry of parabolas or something like that. I think it's called the axis for the parabola, but I don't remember off the top of my head right now. So you could say D has x-coordinate 3 plus 5. No, that was the last question. 2 plus 4 over 2, which is 3. So the y-coordinate for D is going to be -1/2. 3 minus 2, 3 minus 4. Or again, as I say, you could complete the square, but I did that twice in the last question, so I thought I'd do something new. -1/2 times 1 times -1. This will be 1/2. So D has coordinates 3 and 1/2. So it was some positive value. Okay. So I understand D a little better. I understand C. I understand B. I could, if I knew a formula for the area of a triangle in terms of the coordinates, I could use that, certainly. But again, I'm going to not try and rederive that. I'm just going to try and do this question how I think other people might do it. So C here, B here. I don't need A anymore, I don't think. Because all I've got is 3 coordinates. I know everything I need to know about them. It's just a question of what's the area. Now, unlike the ABC, I don't have an easy sort of height that I could drop. Okay? I could do something like figure out the slope of line BC and then get a line through D that's perpendicular to BC, and then get that intersection point E, and then figure out this height, and then you can use distance formulas to figure out the distance between 2 points. You can get the base here and the height there. I think that's going to be a bit messy. I'm not saying it won't work, and I'm not saying you're bad for doing it. I'm just saying I think there might be a better way. And of course, you are free to disagree with me on that. But it seems like a lot of work. It's certainly an attack strategy that would work. So if all else fails, I can go with that. But I'm going to... This is something that I've learned. It pops up occasionally. I mostly remember it from sort of the proof of Pick's theorem, which is a formula for area of lattice polygons. But basically, I'm just going to have a little rectangle that bounds the whole thing. I'm going to have right angles here. So these triangles are going to be fairly simple to compute their areas. And if I know the height here and the base here, I can get the area of the rectangle. So BDC is just the big rectangle minus each of the triangles. That's the plan. Right? And you may argue this is more calculation than the line thing, but it's a calculation I'm a bit more comfortable making. Okay, so I'd probably include this picture, and I'd say, okay, D, you could even label these guys, I don't know, P, Q, and R. B is clearly going to be a corner. But we need to work out some coordinates. Well, P is 0 for the x-axis. It's the same height as D. Q is also the same height as D. And R is going to be the same height as B. And they're going to have the same x-coordinate as my furthest right point, which is C. So that's going to be, 4. Okay, so what do we have? I have a base here of 4. I have a height here of, well, we've got a little half here and then a full 4 here. So this is 4.5. And D is at 3.5. So distance here of 3 and a distance here of 1. And from B up to C, well, C is on the x-axis, so this will be a 4. And so this will have to be a half from C upwards to D. Yeah. Okay, so it's 4 and 4/2. So you might say area of B, C, D is 4 times 4/2 minus 1/2 base times height minus 1/2. It was 3 times, my height was 4/2 there. And then minus the other one, which is 1/2, 1 times 1/2. I can't remember if these numbers are correct, so we'll just go back. 1, 1/2, 3, 4/2, 4, and 4. Okay. So this is going to be 4 and 4/2. We might choose to rewrite this as 4 times 9/2. Minus 1/2, 4 times 4 minus 1/2, 3 times 9/2. Minus, I guess I can simplify that to a quarter. So we'll have 18 minus 8 minus 27 over 4 minus 1 over 4. That's going to be 10 minus 28 over 4, 10 minus 7, a final answer of 3. Okay, shown our calculation. Clearly labeled box picture here shows how I'm getting the area, and again, it's not the only way to get the area. I showed my calculation for D. I showed my calculation for what the parabola is. And that's all we really need to do. So that finishes up question number 7. Up next, question number 8, and then 9 and 10, and then we'll all be done. Okay, won't that be wonderful? So feel free to try question number 8 ahead of time. I'll see you guys in the next video.